Hi, welcome to this lesson on sampling and bias. In the first lesson of this course, you've learned some ways in which statistics can be deceiving. You can show misleading graphs where the y and x-axis are used in an incorrect manner. You can purposefully misinterpret data to get false conclusions, such as that vaccines cause autism. These factors, however, all happen after you've gathered your data. In this lesson, I want to talk about the importance of proper sampling methods and the biases that may come into play when collecting your data. You can be a great statistician and use the correct analytical techniques, but still draw the wrong conclusions based on the unfortunate fact that you gathered your data in a biased way. That will be the topic of this lesson. Let's get started. First, what exactly is sampling? To understand this, you need to understand the differences between descriptive and inferential statistics. We use descriptive statistics when we know all the data points. For instance, all the salaries of the employees in a company. This is what we did in the previous module, as we knew all the data points in our examples. We use inferential statistics when we don't know all the data points. For this, we need to take a sample from the population to make estimates about the whole population. In statistics, the population refers to the total set of observations that can be made. For instance, if we are studying engagement in the company, all of the employees of that company represent the whole population. Inferential statistics takes a representative sample of the population to make inferences about the entire population. This is useful when getting data from each member of an entire population is not convenient or possible. HR uses inferential statistics on a regular basis, as it's often not possible to get data from every person in the company. For instance, to do an engagement or turnover analysis, we often use surveys to gather data from a small sample of the population. Asking thousands and thousands of employees to fill out a 45-minute survey is often just not feasible, and we can still make a lot of good inferences from the data gathered from a few dozen employees. So that's why we use sampling methods. Sampling is a great way to gather data from a group of people and to extrapolate that to a larger population. One of the most common data gathering methods in HR is to use surveys. We use surveys all the time to gather data on a sample, which is a randomized group of people from the company, to answer various questions. What can make or break these surveys are two things: the sampling method, the who you ask, and the questions, the what you ask. We'll talk about both of these in this lesson. Let's first dive into the sampling methods. There are various sampling methods available to HR, each with their own respective pros and cons in terms of accuracy, costs, etc. I'll name them all one by one in their respective uses. First, simple random sampling. Simple random sampling takes a random sample of the population without any partitioning involved. Every person in that population has the same chance of being asked to participate in your survey or study. This minimizes bias and simplifies analysis of results. However, simple random sampling can be vulnerable to certain errors. Because the selection is completely random, the sample may not be an accurate representation of the population. For instance, you want to take a survey based on engagement and use a simple random sampling. On average, you'd expect to get 50% men and 50% women. However, due to randomness, you could get 70% men and only 30% women, or vice versa, of course. This could drastically impact your results if you don't account for sex in your analysis. Both stratified and systematic sampling try to overcome this issue. Systematic sampling relies on collecting a sample from the population through some form of an ordering scheme at regular intervals. For instance, you make a list of all your employees, and every third person in this population is selected to take part in a survey. It is important that the starting point is not automatically the first in the list, but is instead randomly chosen. To determine the ordering scheme, you have to look at the population size and the sample size. For instance, if you want to take a systematic sample from your company of 10,000 employees and want to get a sample of 1,000 employees, you want to pick every 10th person in your list of 10,000 employees, as 10,000 divided by 1,000 is 10. Next, we have stratified sampling. In stratified sampling, each category is seen as an independent subpopulation, out of which the individuals can be randomly selected. Stratified sampling can be excellent when your population has a number of distinct categories. For instance, if you want to make sure every department in your company is sufficiently represented. If you'd use simple random sampling, you might get an overrepresentation of one department over all the others, influencing how valid your statistical analysis is. As can be seen in this picture, you're able to create 3 categories from which each individual is randomly selected. The entire population is heterogeneous, whereas the subpopulations are homogeneous. So you first partition the population into groups, after which you obtain a simple random sample from each group. This will allow you to be more precise about specific subgroups that may be lost in a more generalized random sample. However, it can be more difficult and often more expensive to set up than our previous sampling methods. Fourth, we have cluster sampling. Sometimes it is more cost-effective to select respondents in groups or clusters. Sampling is often clustered by geography or by time periods. Say you want to interview multiple sales officers in multiple countries. It will be more efficient to take 1 or 2 sales officers and interview all the people in those sales offices rather than driving around between each sales office in each country to get a completely random sample. As you may notice, this can only work if the sales offices are similar or homogeneous to one another. However, this type of sampling can significantly reduce administrative and travel costs, while only reducing accuracy by a tiny amount compared to random sampling. To conclude, we have simple random sampling, which is truly random and has the least amount of bias. Next, we have systematic sampling, which collects a sample from the population through a preordained order. We also have stratified sampling, where the population is divided into subcategories, after which the individuals are randomly selected. Finally, we have cluster sampling, where you cluster your samples based on geography or time to make your sampling more cost-effective. There are other sampling methods, such as snowball sampling, multi-stage sampling, but the ones mentioned before are the ones most used in organizational research. An interesting case you may come across is the following. Say the engagement team conducted their annual survey in Department A and Department B. They set out to collect data from as many people as possible from both departments. Department A has 1,000 employees, whereas Department B has 500 employees. Now that they've collected the data, they ask you, the People Analytics department, to analyze the data and to hopefully give them some insights. Opening the data file, you discover that 200 employees of both departments have participated in this survey. How would you create a combined average from these groups? Take a few seconds to think about it, after which I will give the answer. To do this, you need to get the weighted average. When you think of a weighted average, what comes to mind? How would you calculate a weighted average? Once again, take a few seconds to think about it, after which I will give the answer. To get the weighted average, simply multiply the average of each individual group by the proportion of the population they should represent. Those proportions must of course sum to 1. In the case provided, take the average of the Department A survey results and multiply by 0.666. Then, add that to the average of the Department B results, multiplied by 0.333. That will give you the properly weighted average for the survey results. Department B is no longer overrepresented in the survey results, which might have skewed your results and any analysis that would follow. However, having a proper sampling method would have prevented this problem in the first place. To continue, sampling is not the only thing you have to take into account when collecting your data. Like I said in the beginning, what can make or break surveys are 2 things: who you ask the questions and what you ask. This is about the questions themselves. That's the next topic that I will talk about. It may seem obvious, but a survey should measure what it claims to measure. A statistical bias, however, is a statistical flaw which prevents us from measuring the underlying parameter being estimated. In other words, a bias prevents us from getting the results we actually want. This is done in multiple ways. First, you have the confirmation bias. Confirmation bias is the tendency to search for, interpret, favor, and recall information in a way that confirms one's own pre-existing beliefs or hypotheses. This could lead you to designing your survey in such a way that you will most likely find results you are unconsciously looking for. For instance, your survey could have leading or misleading questions. Leading questions are a type of question that implies or contains its own answer. Such a question could be, "Don't you love working under our new performance management system?" Or, "How often do you assist new employees?" Such questions can often make the participant feel pressured in giving an answer appropriate to the situation, even if the survey is anonymous. This is especially the case when it involves sensitive issues, such as engagement, performance, or even sexual harassment. A leading question could be, for instance, "Did you see Mike make inappropriate comments towards Rebecca?" To negate this, try to ask questions that are as neutral as possible. For instance, "What is your experience with the new performance management system?" Or, "Who committed the alleged inappropriate behavior?" However, researchers themselves can often ask leading questions to get the results they want. If they want to show the managers how great the new performance management system is, they can set up a survey in such a way to guarantee a positive response. This negates the entire purpose of such a survey. Be mindful of this bias and point it out wherever you see. Secondly, we have the anchoring bias. Anchoring is a cognitive bias for an individual to rely too heavily on an initial piece of information offered, known as the anchor, when making decisions. Once the value of this anchor is set, all future negotiations, arguments, estimates, etc. are discussed in relation to the anchor. This is often an issue where the ordering of your questions can influence the responses you get. For example, the initial price offered in a salary negotiation sets the standard for the rest of the negotiations, so that salaries higher than the initial salary seem more reasonable even if they are still lower than what the employee would like to receive. Furthermore, the wording of your questions can also set an anchoring bias. If you were to send out two surveys, one asking how fast the cars were going when they collided with each other, where the other asked how fast the cars were going when they bumped into each other, you will get two completely different results. Collided sounds a lot more impactful than simply bumping into each other. Using these words can therefore generate massively different results. Studies have shown that anchoring is very difficult to avoid. For example, in one study, students were given anchors that were obviously wrong. They were asked whether Gandhi died before or after age 9, or before or after age 140. Clearly, neither of these anchors are correct, but when the groups were asked about the actual age that Gandhi died, the two groups still came up with significantly different answers, choosing an average age of 50 for the group anchored with age 9 versus an average age of 67 for the group anchored with age 140. Think carefully about this bias when designing your survey and, similarly to the confirmation bias, try to word your questions as neutral as possible. Third, we have the participation or non-participation bias. With this type of bias, the participants possess certain traits which affect the outcome of the survey. These traits mean that the target population is different from the sample who takes the survey, which can affect the outcome of the survey. An example of participation bias is where you ask a sample of 1,000 managers about their workload. The managers with a high workload may not answer the survey because they don't have time to answer it, and those with a low workload may decline to respond for fear that their supervisors or colleagues view them as surplus employees. Therefore, you will only have respondents who answer somewhere in the middle, rather than the more extreme examples. Another example will be to ask employees about their experiences with the new HR portal. The people who are extremely dissatisfied will be overrepresented in this survey, as they will be the ones most likely to respond and air their frustration. People who are satisfied won't feel the same urge to respond. Fourth, we have the acquiescence bias. This type of bias is also referred to as yay-saying, and is a bias in which respondents to a survey have a tendency to agree with all the questions in the survey. For example, a participant could be asked whether they endorse the following statement: "I prefer to work alone." But then later on in the survey they also endorse, "I prefer to work with others," which are contradictory statements. The best way to reduce this bias is to make a balanced response set, meaning that there are a balanced number of positively and negatively worded questions. This means that, if you want to examine a certain trait with a given questionnaire, half of the questions would have a yes response to identify the trait, and the other half would have a no response to identifying that same trait. That's it for this lesson. I hope you enjoyed this lesson on sampling methods and biases in surveys. In this lesson, we discussed how to use simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Next, we also discussed the biases in our surveys, which can include confirmation bias, anchoring bias, participation or non-participation bias, and acquiescence bias. In the next lesson, I will be discussing probability. Everything in statistics has to do with probability, from sampling the data to analyzing your results. For instance, if you want to know what the chances are that a certain employee leaves, you need to understand probability. So with that said, see you in the next lesson.